We're given a nums array and we need to rotate it to the right by k steps. And what exactly does this mean? Essentially, we want to shift the elements one position to the right, k times. In our example, k equals 3. Rotating one step to the right gives us this array. This is the second rotation and this is the third, and this is our final answer. And how do we solve this? What if k equals 1000? Are we really going to rotate the array to the right 1000 times? If you watched my short on array rotations, you'll know that after n rotations, the array comes back to where it started. So the number of effective rotations we actually need is k modulus n. Now, the most straightforward way to solve this is to rotate the array one step at a time. The important thing here is that before we overwrite a value, we need to preserve it so we don't lose the value that was already there. So before we start, we save the last element in a variable called previous. In this case, previous equals 5. Then we iterate through the array from left to right. At every index, we first save the current value in temp. Then we overwrite the current position with previous. Finally, we move the value we saved in temp into previous so we can carry it to the next index. Once we finish traversing the array, we've shifted every element one position to the right. We repeat this entire process for the total number of effective rotations we calculated. This solution works, but for every rotation, we traverse the entire array. So if there are n elements and r effective rotations, the time complexity is O of n times r and the space complexity is O of 1. But can we do better? Instead of rotating the array one step at a time, what if we could rearrange it directly into its final rotated position? So first, just like in the straightforward approach, we calculate the effective number of rotations. Let's call that r, which is equal to 3 in our example. Now here is an important observation. Let's split the array into two parts where the second part contains exactly the last r elements and the first part contains everything before that. So to rotate the array to the right by r steps, really, the second part needs to come to the front. So a right rotation by r equals to 3 is really this transformation. And how do we get there? We can do it using 3 reversals. First, reverse the entire array. Next, reverse the first r elements, in this case the first 3. Finally, reverse everything after that. And that gives us exactly the rotated array we wanted. And here is the code for this optimized approach. The time complexity drops to O of n, while the space complexity remains O of 1.